All right, guys, we are back with section 5.2, and I think I have some good news for you guys in the fact that this section is not nearly as involved as section 5.1 with the amount of vocab, okay? But what we are talking about are, once again, these special segments within triangles, okay? So in section 5.1, we studied perpendicular bisectors and angle bisectors, and we discussed the point of concurrency of the perpendicular bisectors, which was the circumcenters, and the point of concurrency for the angle bisectors, which is the incenter, okay? So now we're doing two more, okay? And so we're going to start with the median of a triangle. And once again, guys, I have the definitions already written out, all right? So if you need to pause while you write yours down, you can absolutely do that, okay? So the median of a triangle is a segment that connects a vertex and the midpoint of the opposite side, okay? So big concepts here, okay? So midpoint of the opposite side, all right? And connecting a vertex, okay? And I think this should make a little bit of sense to you because I know I've said it in class before, but in math we like to talk about one term meaning multiple things, all right? So if you've already studied about medians in algebra, all right, a median of a data set is the middle of the data set, all right, which kind of connects to the fact that we have the midpoint in this one, which means that the midpoint is the middle of the segment, okay? So if I wanted to draw, all right, the median of this triangle that I've already provided for you, all right, coming from vertex A, okay? So the definition is it's a segment that connects the vertex and the midpoint of the opposite side. So the opposite side of A is side BC, okay? So what I'm going to do first is I'm going to eyeball, all right, the midpoint. And to show that it's a midpoint, I'm going to say, well, this segment has to be congruent to this segment, all right? And then I'm going to draw the segment that connects A with that midpoint, okay? So that's a median right there, okay? All right, now we're going to do that for all three sides, okay? So I'm going to take vertex B, all right? The side opposite of that is AC, and I'm going to eyeball the midpoint, okay? All right, I'm actually going to move that down a little bit more. It's not super great. All right, I'm going to notate it that it's the midpoint, all right? And this time I'm going to put 2 tick marks, okay? And then I'm going to connect B with that midpoint, and that's my other median, okay? Now, if you guys remember what we talked about in section 5.1 is that when you draw all 3 special segments within a triangle for perpendicular bisectors and for angle bisectors, they all met at one point, all right? And that was the point of concurrency. Same idea here, all right? So if we have, once again, all right, this third midpoint, okay, and I'm connecting, first of all, I'm notating, all right, bam, 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 all right, 3 tick marks here, all right? And now I'm connecting C, all right, with that other midpoint right there, okay? All right, now, obviously mine isn't drawn super to scale, but they should have met at one point, all right? And that's our point of concurrency, all right? Now, that point of concurrency, all right, the intersection of the 3 medians is called the centroid. Okay. Now, when we were dealing with perpendicular bisectors, okay, we discovered that the type of triangle forced that circumcenter, all right, for perpendicular bisectors to be either inside the triangle, outside of the triangle, or on the triangle, all right? And we discovered that if the triangle was acute, all right, that was going to be on the inside, all right? If the triangle was obtuse, the circumcenter was going to be on the outside, and if the triangle was right, it was going to be on the triangle, okay? But for angle bisectors, all right, and its point of concurrency, which is the incenter, we discovered that it was always going to be in the inside of the triangle, okay? Same idea for the median, all right? The centroid is always on the inside, all right? It will always be on the inside of that triangle, okay? So if this was an always, sometimes, or never question, all right, it is always on the inside, okay? All right, so the centroid theorem now, all right, This one is going to take a little bit of application. So it says that the centroid is 2/3 the distance from the vertex and 1/3 the distance from the sides. So we're dealing with fractions here, okay? So what I want us to do real quick, all right, is I actually want us to look at this big triangle, all right? And I want us to write out some formulas, okay? So what I'm going to do is I'm just going to focus on one of the medians, all right? And I'm going to focus on this segment of CF, okay? So CF is a median, all right? G is the centroid, okay? Now what I want you to look at is within that median of CF, okay? Do you see how G is not right in the middle, all right? And it's not ever going to be right in the middle, all right? And that even more distinctly, what we have is we have a longer segment, all right? So from G to C, all right, is going to be longer, all right, than from G to F. I don't know why I picked that color. Let's pick a different color, all right, from G to F, okay? So you're always going to have a long segment and a short segment, all right, within that full median, okay? Now, if you want to just look at the theorem real quick, all right, the longer segment is always going to be connecting the centroid and the vertex because that's 2/3 the distance, all right? And it's always going to be the shorter segment whenever it's connecting to the side, okay? But I want to write out some formulas. All right, so what I'm going to do here is I'm going to start with the CG. And I would go through and I'd say, all right, is CG the longer segment or the shorter segment? And I would say, well, it's the longer segment. All right, and then if it's the longer segment, I'm going to be dealing with 2/3. All right, so what I'm going to say now is that the length of CG is going to be equal to the 2/3. And the fraction always has to go with the full segment, all right, the full median. So it's going to be 2/3 the distance of FC. Okay? All right, now let's look at GF. All right, so if we look at GF, that is the smaller of the segments within, all right, the median. And the smaller segment is we're going to use the 1/3. All right, so I'm going to have GF is equal to 1/3. And remember, the fraction always has to go with the full segment of FC. Okay? All right, so 2/3, 1/3. Now, the next connection, all right, and you can do this with all three medians, all right, but the next connection is that we are now comparing CG and GF, all right? And if this is 2/3 and this is 1/3, all right, what you guys are going to see is that it's actually a 2-to-1 ratio when we're comparing, all right, those two segments, which means, all right, that the length of GC is going to be double that, all right, or 2 times that of FG. Okay? All right, and we could do that, all right, with all of the medians. So I'm going to do one more, all right? This time I'm going to write out those formulas, all right, for another one of these medians, okay? So I'm going to look at BD. Okay. Now, BD is my median, all right? G is my centroid, all right? And I'm going to start with BG. All right. So BG is the longer segment within the full median, all right? So BG is the longer segment, which means that has to have the 2/3. And the 2/3, the fraction always has to go with the full segment, all right, which is BD. Okay? All right. Let's now look at GD. All right, GD is the shorter segment, all right, within the full median. And the shorter segment deals with the 1/3. All right, fraction has to go with the full segment, so 1/3 of BD. All right. Last one is we're now going to compare the two segments within the full segment, all right, BG and GD. And we know that it's a 2-to-1 ratio, which means that the length of BG is going to be double that, or 2 times the length of GD. All right, I'm going to pause there, all right, and I'm going to come back and finish this one up.